Hi, that's me on the picture flash on the screen right now. Just a short story. I am a type of kid who loves to play outside, usually in dirty places, considering that I grew up in a not much developed area in Pasay City. And whenever I tried to play outside, back when I was a kid, my mom used to tell me, "Huwag ka nga dyan, alam mo na nga makalawang dyan ka pa naglalaro. Paano kung matetano ka?" At a very young age, I was introduced to the idea of corrosion in a form of rust and how it could be fatal to one's life. Interestingly, with me being an aeronautical engineering student for 4 years, the same idea still applies. Corrosion remains fatal. Good day, my name is Adrian Renacia, the presenting author of our study titled Ipil-ipil seed extract as a potential corrosion inhibitor additive on epoxy primer applied on mild steel. In a spectrum of airline fleets, looking at the individual aircrafts, we know that majority of its components are made of metal. For instance, in a Boeing 737, approximately 80% of it is made of metal, which in nature is expected to experience corrosion. Although there have been innovative solutions being used in today's commercial status, we cannot demerit the fact that these solutions come with its respective drawbacks, hence a window to find the research gaps. For instance, the aviation industry has been using interventions such as phosphate and chromate treatment. Although both of these are known to be effective, both options poses threats to humans and the environment. In fact, according to the National Institute of Environmental Health Sciences, hexavalent chromium, which is a component for chromate treatment, is hazardous and carcinogenic, leading to it being banned in Europe since 2007. With this in mind, we have thought of why not improve an aircraft staple instead of having the metal parts go through chemical treatments just to implement preventive actions against corrosion, thus the epoxy primer. Relatively among the pre-treatment techniques that have been conventionally applied to aircraft parts is through the use of epoxy primer, which serves as a base coat before bare steels are ready for a paint job. Because of their excellent adhesion, good mechanical properties, and long-lasting chemical resistance in wet and high humidity settings, epoxy primers are used for a wide range of materials, including aircraft parts. As a matter of fact, according to Gopal in 2021, in applying epoxy primers on bare steel, its thickness affects how well it can protect against corrosion. The thicker the epoxy primer layer, the better. With this rationale, regardless of what model, how old the aircraft is, who its operator is, the epoxy primer will remain be of use. Knowing this, we wanted to optimize the epoxy primer so that along its mechanical properties, with the help of a bioadditive, it will also possess a corrosion inhibition property. Given that the main issue with the previous treatment techniques involves human and environmental hazards, we have opted to look into biosources that we believe has a great potential of becoming a biocorrosion inhibitor additive. This is where the Lucena leucocephala or ipil-ipil seed extract comes into the equation. So what made us think that the LL seed extract has a great potential of becoming a biocorrosion inhibitor additive? Primarily, it is because of its contents, wherein in a study by Sojipto in 2019 titled Fatty Acid Composition and Total Lipid Content of the Seed Oil of Lucena leucocephala, he mentioned that aside from mimosine, alkaloid, saponin, anthraquinone, steroid, flavonoid, and tannin, it also contains lipid, carbohydrate, protein, which made it a viable bioinhibitor for copper and mild steel corrosion. Now, the challenge lies in how can we prove of this potential and how well the LLC extract improve the epoxy primer. For this study, we have opted to rely on testing methods that can give us numerical values to quantify the impact of the additive on the epoxy primer as it is being applied to mild steel. Presented is the outline of the entire methodology that we have followed for us to carry out the study, starting from the gathering of the raw LO seeds and then processing it to become an extract and finally mixing it to the epoxy primer to serve as a biocorrosion inhibitor additive. With that, our testing methods were based on two matrices that we would like to focus our investigation on: physical and electrochemical matrices. For the physical matrix, we went for a surface analysis testing method, which is called atomic force microscopy testing or AFM test. Whereas for the electrochemical matrix, we opted to measure the impedance values for each setup. Thus, we use electrochemical impedance spectroscopy or EIS test. Relative to the setups we have established, we have a total of 6 setups. Setup O, A, B, C, D, and E. Setup O being the bare mild steel sheet, setup A being coated by epoxy primer only, and setups B, C, D, and E being coated by epoxy primer with an LLC extract additive with a variation in the concentration of the extract from 3%, 6%, 9%, and 12%. The results of the experiments show that the LLC extract really has the potential of being an inhibitor for preventing the corrosion of matte steel in a 0.6 molarity per liter sodium chloride environment. The obtained inhibition efficiency shows an increase with rising inhibitor concentrations. Further information about the inhibitory qualities can be gained through electrochemical impedance spectroscopy or EIS test. Since the observed rise in charge transfer resistant values denotes the creation of a protective surface film after the addition of the inhibitor. While based on AFM analysis, the surface of the coating with the optimal concentration of LLC extract shows a smoother surface with few crystal-like structures or difference on roughness average between pre-test and post-test of EIS, indicating an increase in its capabilities as a corrosion inhibitor when compared to the same coating without the presence of the extract. Together, the results show that the LLC extract has really the potential to be an effective corrosion inhibitor for mild steel and chloride-rich conditions, opening up possibilities for its practical use in methods for corrosion protection and prevention. With this, allow me to ask you, are you willing to be with us as we embark on an innovative venture without further compromising the environment's welfare? And the answer is yes. Join us as we move further. That would be all. Thank you for listening.